Hello, Algebra 2A, welcome back. And today we are on lesson 15, looking at systems of equations and solving them by graphing. So our one goal today is to solve systems of equations by graphing. And all the equations that we're going to use today are linear, which means they form a line, like we talked about in lesson 13. A couple of new concepts before we start. A system of equations is a collection of two or more equations containing two or more variables. A linear system contains only linear equations. So everything that we see today will produce lines. Intersect. The point of intersection is where we're going to find the solution. The solution is going to be an XY ordered pair. So let's get started. We will start with example 1. We're going to solve a system of equations by graphing. To graph each of these, we are first going to put them into slope-intercept form, which means we need to have the y solved out on one side and then move all our other terms to the other side of the equal sign. So I'm going to keep the y on the left side, and I'm going to undo this negative 2x. I'm going to add 2x. To undo plus 4, I'm going to subtract 4. And we're left with our result of y equals 2x minus 4, which is in nice slope-intercept form. Now we'll work on our second equation, y plus x equals negative 1. So I'll start by moving the x, subtracting x over to the other side, and now we'll be in slope-intercept form. So notice I did not combine the negative x with negative 1. Those are different terms. So we've got our y equals negative x minus 1. It's also a good idea if you are working with multiple equations, if you do have two colors, so that we can keep them separate and we can kind of see that color coding happening as we work. Once we have both in slope-intercept form, we will find the slope, and I already wrote the slope as a fraction so we can see the rise over the run, and find our y-intercept. So the b value is negative 4, which means that it's crossing the y-axis at 0, negative 4. Over here, we got a slope of negative 1 over 1, and then our b value is negative 1, so our y-intercept is 0, negative 1. Only thing left to do is to graph, and then when I get back, we'll talk about the point of intersection. So once we have both of the lines graphed, we will now look for that solution, and that solution is where your two lines intersect. So I'm keeping the color coding consistent. This is my red equation, 2x minus 4. This is my blue equation, negative 1x minus 1. And I'm focused in on this intersection, which we're going to arrow in here in green. So right there is my intersection, and I'm going to use the x and y coordinate to that point. So it's an x coordinate of 1, y coordinate of negative 2. So there would represent my solution, 1, negative 2. So that is how you write your answer to the system of equations. In part B, we are going to make a table of values for each equation to solve the system in part A. And I am going to show you how to make a table of values in your TI graphing calculator, which you all have access to. If you go to your class page, if you click on this calculator right here, you will be able to see that. And of course, if you have your handheld calculator, you can get that ready to go, take that out right now. Once you have your calculator open, you're going to hit this y equals, and we're going to let's keep the color coding consistent since mine has color. I'm going to put the blue equation into the y1, so y equals, I'm going to go negative. Oops, that's the minus sign. You want to hit this one down here. Negative. X is your button right next to alpha, X. And then we'll hit the subtract sign. So there is a difference. You will get an error message if you use those the wrong way, but there we go, negative x minus 1. And the red equation, we're going to have 2 go up to my x minus 4. Once you have those in, if you do hit graph, it will show a picture just like we drew on our graph on our notes. But what we want to do is we want to look at the table. So we're going to solve this using a table. If you go to second graph, which you see this table up here, it'll show a table. Now, where is that solution? So the solution we already know is at 1, negative 2. But how to find it in a table is you're looking for when are both of my y's going to be the same. So you're looking at just the blue and the red y's. When are they both the same? Well, if you go down to 1, negative 2, here's where both of those are the same. That's that point of intersection. So we can use our graphing calculator, put both of our equations in, as into our y equals, and then head to your table and you're looking for where are both of those y's the same. They're the same at 1, -2. So there again is your solution. In example 2, I'm going to show you how to graph a system of equations in your calculator, then using the intersect function on your calculator to find a solution. So in example 2, we want to solve this system by graphing again, but I do want to show you on your TI calculator how to find that intersection as well. Before we can put them into our calculator, we have to get both of them into slope-intercept form. So let's start by solving each of these for y. To start out, if I move and add this y over to this side, I will have -5x plus y equals 2. Our next step then is to move the x back to the other side, so we're going to do the opposite of -5x. We'll add 5x to both sides. And we get our answer in slope-intercept form. So our slope would be 5, y-intercept would be 2, but now it's ready to put into our y equals. Now we're ready for the next one. Again, we're looking to get y alone, so we have a positive 3x. We'll subtract 3x to the other side. And with that one step, we are already into slope-intercept form. So next, I will take out my calculator, so go ahead and get that ready to go again. So we'll head back to our calculator where our last problem is still in there. When we use the table to solve, we're clear out, and then our blue equation we'll put in 5x plus 2, and our red equation, -3x minus 1. After those are both in there, you can hit graph. Sometimes you may not see the intersection. We'll talk about that when we get to it. We'll have to adjust our window, but there's our intersection right there. It's kind of hard to tell exactly where that is. So the next thing that I'm going to teach you is how to use your calculator function of intersect to find that intersection. So what you'll do next is you'll hit second trace, which has the calc above it. You go down to number 5, you hit intersect, and then once you hit intersect, it's going to ask you which line is the first line, the blue one. Hit enter again on the red line, hit enter again when it says guess, and we've found our solution. So this strategy can be used for any system of equations. You can use that intersect and you can find exactly where those points are. Especially on this one, if we graphed it out, it'd be hard to tell exactly where they cross each other. So this would be a good one to use technology so that we can find exactly what the solution is. So our solution is 375 thousandths and 125 thousandths. So there would be our two XY coordinates. Now, as we've been talking about systems so far, you maybe have been thinking about some unique situations, and there are some unique things that can happen. So we're going to talk about the different types of way to classify systems. First, a consistent system means it has at least one solution. And we've seen some systems so far that have solutions. Inconsistent has no solutions. So you might want to start thinking about, well, what type of lines, if we're talking about a system like 2 or more lines, what type of lines would not have solutions, that would not intersect? A dependent system is a system that has infinite solutions, and then an independent system has exactly one solution. Both a dependent and independent system are consistent because they have a solution. I think to help us with these classifications, it helps to look at a picture. So we're going to draw a picture of each type of situation, starting with lines that intersect at one point. So we've seen these before. Lines that intersect at one point have exactly one solution. So these are the independent solutions. So again, I would classify this as a consistent independent system. Our second situation is lines that coincide. Coincide comes from the word coincidence. So sometimes you say it's a coincidence that you meet somebody at the same place, or it's a coincidence that two things happen at the same time. Well, we have a lines that coincide means that two lines are doing the exact same thing. And if these two lines are doing the exact same slope, same y-intercept, they're always touching each other, which means that they would have infinite solutions. So we're going to classify this as consistent dependent. And lastly, if lines are parallel, and you should know that definition from geometry, if lines are parallel, they'll never intersect, which means that they will have no solution. So we'll classify this one as independent. inconsistent. So hopefully you're already kind of thinking about that, knowing that two lines that intersect at one spot have one solution. If they don't intersect, they will have no solutions, which means that they are parallel. So lines that are parallel will have no solution. Some other patterns we'll see with these classifications is when we have an inconsistent system, that's going to mean the lines are parallel. They'll have the exact same slope and a different y-intercept. If we're talking about a dependent system, they'll both have the same slope and the same y-intercept because they have to be the exact same line. And independent, all we're looking for is that we have a different slope. If two lines have a different slope, eventually they will intersect each other. So we'll head down and look at these systems of equations and decide whether they are inconsistent, consistent independent, or consistent dependent. I'm going to use another graphing program called Desmos for this one. So we'll take a look at that program. If you are in my class, you can now find that on the schedule. If you click this Desmos icon, that will give you the option to go to Desmos. Once you're in Desmos, you can put your equations in, and the nice thing about Desmos is you do not need a equation in slope-intercept form. You can put them in as is. So there's our 3x plus 2y equals 4. Next, we'll do 6x plus 4y equals 8. And as we look at it, and I'll kind of show you again as I shut this off, turn it on, our two lines are exactly the same. So that one would be a consistent dependent, so infinite solutions. To delete those equations, you can hit the X, delete those out, and then now we're ready for our next one. So our next one will hit x equals 3, and we'll go x plus y equals 6. And we look at our x equals 3 is a vertical, our x plus y equals 6 is a linear going at a slope of -1. And we can click there, we have our solutions. The nice thing about Desmos 2 is the intersection. You can always find it by clicking on it. But either case, you've got two lines with different slopes that intersect at one spot. This would be consistent independent. And after I've deleted those two out, we'll try our last one. So we're going to have y equals 2x plus 1. Secondly, we'll have y equals 2x minus 3. And once we get both of those graphed out, we've got a black line heading at a slope of 3, a red line. Looks like we got some Monte colors going. Now we have our two lines going at a parallel. You can tell that by the slopes here. So now we have our first inconsistent system. And there you have it. We've used our visual in Desmos to identify a consistent dependent, a consistent independent, and lastly, an inconsistent system. To finish up, we'll look at a story problem where we want to find an intersection. So we want to find when two companies have the exact same cost. So a cell phone company charges $60 or 60 cents for each text message for customers not enrolled in a plan. Customers in the plan pay $10 each month and 10 cents for each text message. After how many text messages will the total cost be the same for members and non-members? When you're reading a story problem, in that last sentence will tell us a couple of things. It'll tell us our variables. So our text messages, X, are going to depend on our total cost, Y. So we're going to start by identifying our two variables. Now we can start to build our equation. The first company charges 60 cents for each text message. And anytime we see that keyword each, that's going to mean that we're going to use multiplication times. So there's our first situation. Our first company is going to charge 60 cents per text message. So I'll go 0.60 times X. Our second company charges $10 each month and 10 cents per text message. So over here, my 10 cents per text message, I'm going to use multiplication when I see that each here. And text message is my variable, so I'm going to go 10 cents times X. Now I'm not talking anything, there's no variable for each month, so that's just a standard monthly cost. So I'm going to add that on. That's going to be like my y-intercept. So I start the month at $10, and then my increase is going to be 10 cents per text message. So the next thing we want to do now is graph this out, and I'm going to choose to use Desmos to graph it. So once in Desmos, I'll put both those equations in. I made my blue equation blue. Can do that just by holding down, and then you can pick the color. And then I made my red equation red. So we'll look at our Desmos, and let's enlarge this now since we're onto this. You can zoom out by using the minus sign up here. Zoom in using the plus sign. So we can start to see here's our $10 at the beginning of the month, 10 cents per text message goes to here. As I continue to use 60 cents per text message, it's also going to meet up right there. So we should have probably noticed that the two slopes were different, which is going to cause us to get an intersection at 2012. So going back to identifying our variables, X represents text message. So at 20 texts, the total cost is going to be $12. And that's when the two companies are the same. So there's decisions that come up like this depending on the cost of some type of service. So if you're using less than 20 texts, it would be cheaper to use the 60 cents, the blue method. If you're going to send over 20 texts, it would end up being cheaper for using the red equation. Well, that covers lesson 15. We are now going to be ready for our practice in lesson 15. Thanks for joining. We've covered our one learning target today was to solve systems of linear equations by graphing. Thanks for joining. We'll see you next time.